Okay, the next thing we're going to look at is a first derivative test. So we use the first derivative test to find, oh my, let's try again, shall we? Oh my goodness. Got really crazy there for a second. To find where my graph is increasing or decreasing and the local extrema. All right, so that's what we're going to use our first derivative test for. Oops. And we're going to use it, and it's going to help us with our graphing. Okay, so let's look at example 3 here. Example 3 says, find the intervals of increasing and decreasing and any local extrema. Okay, here's my function. F of x is equal to 3x to the 4th minus 4x cubed minus 6x squared plus 12x plus 1. Okay, let's do it. So the first thing I'm going to do, anytime I'm trying to find local extrema like we just talked about, you've got to get those critical values. You're setting your derivative equal to 0. That's what you're doing for your first derivative test. Set that derivative equal to 0. So if we're going to have a first derivative test, we got to find a first derivative. So let's do it right now. F prime of x is now equal to a 12x cubed minus 12x squared minus 12x plus 12. Holy cow, it's a lot of 12s. Right? Okay. So we're going to set this bad boy equal to 0. But I'm not going to do it like this. We got to do some algebra first. To find our critical values, we need to factor. So get back to those algebra roots. Factor this out. Well, obviously there's a 12 in common, so let's get those bad boys out of the way so we can actually see what we have to work with here. All right, I've got 4 terms with nothing in common, so we're going to do some factor by grouping. Still just factoring, kicking it back to those algebra skills. I've got that 12. So I've got an x squared in common with that first term, leaving me an x minus 1. A negative 1 in common with that second term, leaving me with an x minus 1. Remember, the whole point of factor by grouping is that you get the same thing in parentheses. So I actually end up with x minus 1 and an x squared minus 1. Right? Because you take this x minus 1 and factor it out from both, and I'm left with x squared minus 1. But I've got the difference of squares, so I can factor that again. So I've got x minus 1, and I've got x plus 1, x minus 1. Now, anytime you have the exact same thing here, put it together. So my derivative is 12 x minus 1 squared and x plus 1. That is my derivative, and that is what we're going to set equal to 0. All right, that's how we get our critical values. So I'm going to scoot it up a little bit. So 12 times x minus 1 squared times x plus 1 equals 0. So x is a 1 and x is a negative 1, right? Those are my critical values. Now here's how I do this. As soon as I get the critical values, I like to make a chart. With this chart, then I'm going to figure out, is my graph increasing or decreasing? So I'm going to have the interval. Then I'm going to say, is my first derivative positive or negative? Because that's going to tell me the slope, right? And then that determines if my graph is increasing or decreasing. So you have to come up with all your intervals around the critical values. So I'm going to go from negative infinity to negative 1, negative 1 to 1, and then 1 to infinity. It's where my critical values, all the intervals that go around my critical values. That's the key. All right? I only care if this is positive or negative. That's it. I don't care about anything else. So just pick some value that's in the interval. So negative 2, something easy. And then I'm going to take this negative 2 and plug it into the derivative. Here's the other beauty, guys. Whenever I'm looking at this, I'm plugging it into what's factored out because it's easy. Easy. So negative 2, if I plug it in here, I've got negative 2 and minus 1. But what happens when you square that? You get a positive number because it's squared. Now when I plug a negative 2 into here, what do you get? A negative number. Good. And I'm multiplying both of these by 12. That's a positive number. So it's a positive times a negative is going to equal a negative number. If this whole thing is negative, then I know that I am decreasing. Right? Okay. Decreasing. I've got plenty of room. I might as well write it out, huh? All right. So let's do our next one. Come up with the first derivative of, let's go with 0 because that's super easy. So I'm going to plug a 0 in here, but again, it's squared, so that's positive. And if I plug a 0 in here, 0 plus 1 is still another positive term. So if that's positive, then I am increasing. Now let's plug something in over here. 2. 2 isn't easy in my interval, so 2's in this interval. You could pick any number you want in that interval. I am choosing these numbers because they're easier to work with. That's the literal only reason. So when I take my 2 and plug it in, when I square it, that's positive. Take my 2 and plug it in. I have a positive times a positive, so I know my graph is increasing here. Right? Okay, so let's talk about what's happening. If my graph is going from decreasing, right, decreasing to increasing, because that's what's happening right here, decreasing to increasing, what does that make? A minimum. So at x is equal to negative 1, I have a minimum. Then what happens when I am increasing to increasing? We just did that, right? Increasing to increasing, but my critical value is where it's set equal to 0, so what happens to my graph? Yeah, flattens out. So at x equals 1, then my graph flattens. I expect you to know that, all right? You still have that critical value, so with that critical value, what's the behavior of my graph? Good. First derivative test, increasing or decreasing. Okay, let's try another.